Okay, welcome back. I'm going to be going through some word problems today. These are actually taken from my calculus class, so a little bit advanced, but we'll walk through them. Okay, I've got right now Kelly and Tommy on Zoom. And I see Niall on Skype. Oh, Sarah too on Zoom. Okay, so objectives today. We're going to use relationships between derivatives and integrals to interpret the meaning of accumulated rates of change and derived rates, and then estimate derivatives and integrals graphically. So here I've got a function of calories per minute every minute given graphically on the right. So my function here, f of t, is measured in calories per minute, and t is measured in minutes. This is a piecewise function, which means we can define it differently at different times. So from 0 to 4, our piecewise function is modeled by f of t equals negative 1/4 t cubed plus 3/2 t squared plus 1. After t equals 4, we have 4 separate linear functions that could model our graph. So from 4 to 12 is 1, 12 to 16, 16 to 20, and 20 to 24. 4 different piecewise linear functions. Okay, first part. I'm going to jump over to, let's see, I've got Kelly first on my list. So for part A, I want to find the derivative at 22 and indicate my units of measure. So how can I get the slope of f at t equals 22? Oh. Okay, I can hear you talking again. Let me turn you up. Okay, that's speakers. Okay, can you try again?
I'll derive the formula first and then put 22 for t.
Okay, our problem with that is if I try to derive the formula first, our formula is only true for t equals 0 to 4. So at t equals 22, that formula won't apply.
Find the slope between a
Okay, I heard you say it, I think. So we need to find the slope. How can I get the slope of this line?
the slope between 2015 and 2043.
Yep, between 2015 and 24.3, what would the slope of that line be? Since we were told it is linear.
12 over negative 1.
Perfect. Okay, so that was y2 minus y1 over x2 minus x1, or 15 minus 3. Oops, I should probably do this the other way actually. y2. 3 minus 15 over 24 minus 20. Or Negative 12 over 4 is negative 3. And then what are my units?
Calories per minute.
So f of t is measured in calories per minute. So what should f prime of t be?
Calories per minute squared.
That's it. Calories per minute, or calories per minute squared. So that tells us that our calories per minute are decreasing by 3 every minute. Okay, any questions on part A?
No.
Okay, I'm going to show you, this is College Board's scoring guide. So College Board is the organization that makes all the AP tests, but also the SAT and ACT. So this is how they would score you. Over here on the right is how what they would give the teachers who are grading your test. And this is their sample work. So you've got 1 point for setting up f prime at 22. So they're not looking at your answer, they're looking at your setup. F prime at 22 is an average slope. And in order to get that point, you must have units. Calories per minute, or calories per minute squared. Okay. Part B is a little bit involved, so I'm going to start going through it myself and then call on people as we get to each piece. So on the time interval from 0 to 24, we want to know what time f is increasing at the greatest rate, and then show the reasoning that supports our answer. So first, my next person is Sarah. F of t is shown here. Once again, this graph is f of t. On what time intervals, so from what time to what time, is this graph increasing? Okay, let me grab Sarah again. I need to know when this graph is increasing. Okay, so there's 2 places where this graph is increasing. So from what time to what time are we increasing? Okay, I think you're breaking up a bit. I've got 2 times where we're increasing. Can someone tell me the first one?
0 to 4.
Okay, I'm increasing from 0 to 4. And where else?
12 to 16.
Okay, 12 to 16. Okay, so from 12 to 16 is another linear function. In order to figure out how fast this equation is increasing, we would need to derive again, which is the same process that we did last time. So we can get our slope from t equals 12 to t equals 16 using our average slope. So I'm going to jump over to, let's see, I've got people on Skype now. Oh, we've got a lot of people on Skype. Let's do Niall. What's my slope from 12 to 16?
The slope from 12 to 16 is 6.
Okay, can you set it up for me? So what did you do?
Like, since the y-intercept distance between 12 and 16 is 6.
For my average slope, this is y2 minus y1 over x2 minus x1. So how can we set this up?
Oh, so it's 6 over 4.
Okay, so this
Yeah,
is
6.
15 minus 9 over 16 minus 12. Okay, so that's 6 over 4 or positive 3 over 2. What are my units for that? Miss off a little bit of space.
Is is it? Uh, is it FT over T?
Yes. So the units should be what?
Calories per minute over minutes.
Perfect. Calories per minute over minutes, which would be calories per minute squared. If you have calories per minute over minute, that's the same thing as calories per minute times 1 over minute, or calories per minute squared. Okay, so we've got our derivative, or our slope of the linear function from 12 to 16. So we know how fast it's increasing. For the second part of this, though, we'll be looking at our interval from 0 to 4, which is not a linear function, is this function instead. Who do I have next? I've got Eileen next over on Zoom. How can I get a slope for our interval from 0 to 4?
So 9 minus 0.
Okay, so that would be, if this was a linear function, then we could get our average slope, but our function is not linear from 0 to 4. So we've got a formula instead.
So you substitute 4.
Substitute for, okay, let's get a general form first. So if I'm looking for how fast this is increasing, I'm looking for a slope. If I know our equation is here,
Derive.
we can derive. Okay, so we're going to derive once to get our general form. Okay, 6t over 2, so that's 3t. Okay, so that's our first derivative. That'll tell us how fast we're going. And we would need to plug in a time between 0 and 4 in order to make that work. Okay. in order to figure out at what time between 0 and 4 this is growing the fastest, we can maximize this derivative. So to maximize a function, normally we derive it, set the derivative equal to 0, and solve for x, which is what we're going to do here. So this is our rate on t equals 0 to t equals 4. And to find the maximum, we'll have to derive this again and set it equal to 0 to solve for x. Oops. F prime prime of t. Okay, what's my second derivative right now?
6 over 4.
Negative 6 over 4. Okay, so that's negative 3 over 2 times t
Plus 3.
plus 3. Okay, so I'm going to set that equal to 0.
We sub that to 0.
So if I set this equal to 0, what's going to happen?
Equals -3 divided by -3 times 2. 3.
Okay, you're right. Negative 3 times 2 is negative 6. Divided by the negative 3 is 2. So at t equals 2, our slope is changing from, if I plug in t equals 0 right now to our second derivative, I get a positive value. If I plug in t equals 4 right now to my second derivative, I would get a negative value. So my slope is maximized at t equals 2. F prime t is maximized. Remember, whenever we've got a slope of 0, and we change from a positive slope to a negative slope, we have a maximum value, which is what we just proved. So we took a look at our first derivative and derived it again to figure out what the slope of the first derivative is, found the point when the slope of the first derivative was 0, and changed from positive to negative to maximize f prime. F prime will be as big as possible when t is 2. Okay, so I can use that. Oh. Had someone asking a question, I think. Say again.
Oh, sorry, somebody was speaking in my room.
Okay, no problem. So then I'm going to plug in 2 into f prime t, and we'll see how big f prime t gets when we're at a maximum. So we said, I'm going to jump to the next slide, I think, just to give us some more space. F prime t was equal to negative 3/4 t squared plus 3t. At 2, what will this become? Who do I have left? I've got Tommy in the lineup. So Tommy, what is f prime at 2? Okay, maybe not here. So next is Kenichi. Kenichi, if I plug in 2 right now, what's going to happen?
Hello, can you hear me?
I can hear you.
Okay, if you plug in 2, it's gonna be negative 3 plus 6, which
Okay,
becomes 3.
3, perfect. So my derivative is 3. Okay, so going back, we said our slope, that's our derivative, from 12 to 16 was 3 over 2. And our slope from t equals 0 to t equals 4 was 3. So, which time are we increasing at the greatest rate?
I'm not sure.
Okay, I'm going to open up to anyone then. At what time is the slope maximized, as big as possible?
Oh, 16?
At t equals 16, we said our slope was 3 halves, but there is a point where where our slope is larger than that.
Oh, no. Below 16. So 15.
So for this whole interval, oops. For this whole interval here in this laser point, this whole interval here, our slope is 3 halves.
Okay.
Okay, for this interval, our slope is changing, but we said our slope is as large as possible at t equals 2, where our slope was 3.
Okay.
So at what time is the slope as large as possible for this function? Okay, I'm going to go back again. So we have f of t measured in calories per minute. We're trying to figure out when it's increasing at the greatest rate. So I want to know when the slope of f is as large as possible. We said f is only increasing from 0 to 4 and from 12 to 16. From 12 to 16, our slope is constant because this is a linear function. Our slope for all of those points from 12 to 16 is 3 over 2 calories per minute squared. Our slope from 0 to 4 is constantly changing. It would be according to our derivative of f, which we said was negative 3/4 t squared plus 3t. In order to figure out when this will be as large as possible, we can maximize it using optimization. So to optimize this derivative, I would derive it one more time, set the derivative equal to 0, and solve for t. That will tell us any points where the slope is 0. Our slope was 0 at t equals 2, and we changed from positive to negative, which tells us that that's the maximum of the function. At t equals 2, our slope was 3. So from 0 to 4, our maximum slope is 3. And from 12 to 16, our slope is constant, 3 over 2. So for the entire graph, 0 to 24, where is the slope of f of t as big as possible? What time? Anyone?
0 to 4.
0 to 4, more specifically, what time?
2.
2, perfect. Okay, so we could say f prime t is maximized at t equals 2. So f is increasing at the greatest rate. At t equals 2. Okay, here's how they would score you. So first, we've got 1 point for taking the derivative on 0 to 4. So that's 1 point for checking the derivative here. 1 point for maximizing and finding t equals 2. 1 point for testing the slope on 12 to 16, so that's our average slope, against our slope at 2. And then 1 point for our answer, where we're increasing as large as possible at 2. Okay, so again, it's really important on your AP exams to show your work, regardless of which math you choose to take next year. If you just said t equals 2, you would only get 1 out of 4 points for this. Okay, part C. We are back at the top of the order, so this is back to Kelly. I want to find the total number of calories that we burned from t equals 6 to t equals 18 minutes. Okay, if I'm looking for the total number of calories that we burned, and right now we have a function of calories per minute, what do I have to do?
Like,
Can you say one more time?
can you repeat the question?
Right, so we're working on C. We want to find the total number of calories burned from 6 minutes to 18 minutes. Right now we have a function that is calories per minute at any minute. So what do I have to do to get the number of calories? Integrate, perfect. So what we want to do is we want to integrate from 6 to 18 of f of t dt. I'm going to rewrite that f because that looks like an f prime. F. Okay. So I want to integrate. We don't have a function though, we just have a graph. So to integrate, since integration is the area underneath the curve, we're just going to break this apart into different shapes and get the areas. Kelly, I'm going to stick with you for the first shape, and then I'll move to the next person. So from t equals 6 to t equals 12, what shape can I use to get the area?
Rectangle.
Rectangle. Okay, so that's from 6 to 12. What would the sides of the rectangle be?
6 and 9.
Okay, 6 and 9. Perfect. So what's the area?
36.
Not 36?
54.
54, okay. 54. Okay, so that's our first area. Okay, then I'm going to go to the next person. I've got Sarah next. From t equals 12 to t equals 16, what shape could I use? Or if you want to use two shapes, you can use two shapes if that's easier for you. Might have lost Sarah. Sarah, are you with us? Oh, okay. From t equals 12 to t equals 16, what shape can we use to get the integral? So what shape can we use to get the area? If you want to use two shapes, you can do that instead. If you want to use one shape, you can give me that. Okay, if you want to use a rectangle, then we can split this up into two shapes. So here I've got one rectangle in green, and then we'll also need a triangle for the top. So let's look at the rectangle first. What are the side lengths of that rectangle? I'm going to throw your chat up so everyone can see. Okay, so we've got a rectangle. What are the side lengths of the rectangle in green? Okay, so I've got 9 and 4, perfect. So that's 36. And then we've also got this triangle here, which would be a 4 by 6 triangle. So what's our area of the triangle then? What's the area of the triangle on top?
Well,
12, perfect. Okay, and then our last part, we are continuing to 18. So from 16 to 18. Who's next? I've got Niall next. From 16 to 18, what shape can we use?
16 to 18. We can use rectangle.
Okay, I can use a rectangle. So here's my rectangle here in blue. What's the area of that rectangle?
Area of the rectangle, so is 15 to 30.
Okay, 30. So I'm going to add all of this up, and we should get our estimate for the integral. So if I add all of this up, I've got, let's see, the 36 and the 30 is 66, plus the 54 is 116 plus 12. So I had originally fourth. Okay, I had the 54, that's right. Fourth, it's 2 by 26. I've got less than I expected. Oh, well, we'll keep going. So I've got 30 and 36 is 66. So I've got 70, 120, 132. Okay, and that does match. I'm just going crazy. So 132 calories. Write this in white. Okay, calories, because we integrated. When we integrate, we multiply the units together. So this was calories per minute times minutes. Gives us calories. Any questions on C? Okay, last one. Oh, just show the scoring first. Okay, here's the scoring guide. So we've got 1 point for the method, which is getting areas. They did use a trapezoid for this middle space from 12 to 16, which is okay too if you want to do that in one shape. So that would be the average of your heights, 9 and 15 divided by 2, times your base of 4. But if you wanted to break that up into a rectangle and a triangle like we did, that'd be okay too. Okay, for part D. Our settings change so that the person now burns FT plus C calories per minute. Find the constant C so that an average of 15 calories per minute is burned during the time interval from 6 to 18. Okay, so first, last week we talked about a formula for average value. Does anyone remember the formula? This might have been 2 weeks ago, I don't remember. Okay, so my average value is 1 over b minus a times the integral from a to b of f of t dt. So what this does is, let's say f of t is a velocity. When I integrate, I'll get my displacement, and then you divide by how much time passed to get an average velocity. So I'm integrating, which would step up with your units, but then you're dividing by your total amount of time that passed, so you step back down with your units, and you end up right back where you started with your units. So units do not change in this formula at all. But it takes us from having a formula that gives us an exact amount at any time, and gives us an average over that period of time. When you think about what an average is just for a set of numbers, you add up all of your numbers and divide by, so I'm going to say sum of x, and divide by the number of numbers in the set, which is exactly what we're doing here. I'm adding up all of our values, so that's when you integrate f of t, you're adding every possible y value together in order to get a total. But then you're dividing by the total number of values in that space in order to get an average. So the idea is kind of the same as what we do with discrete numbers, but this time we've got a whole function instead. Okay, I can see Kelly's got her mic on. Kelly, do you have a question? Nope.
No.
Okay, cool. So going back to this then. So we've got our formula for average value. I want our average value to be equal to 15. So my average value, I'm not writing red. So I'm slightly colorblind, and that red on blue throws me off. 1 over b minus a, so that's 1 over 18 minus 6, times the integral from 6 to 18 of our function, which is now f of t plus c. Some constant c we don't know in terms of time, should be equal to 15. I want my average value of f of t plus c to be equal to 15. Okay, any questions on our setup so far? Okay. So I can split this apart. This is 1 over 12 times the integral from 6 to 18 of f of t plus the integral from 6 to 18 of c in terms of time. Should be equal to 15. And we actually already found the integral from 6 to 18 of f of t last time. The integral from 6 to 18 of f of t we said was 132. So we can substitute. So this is 1 over 12 times 132 plus, if I integrate a constant in terms of time, what will happen? Get rid of this line to make it a little bit cleaner. I want to integrate c in terms of time from 6 to 18, where c is some constant. So if I integrate a constant, what will happen? Anyone? If it helps, I could rewrite that constant. My constant is c times t to the 0 power because there are no t's. Anything to the 0 power is 1.
CT to the first.
Perfect. So this is going to end up being ct to the first power divided by 1, or just ct. Okay, and it's going to change from 6 to 18. So I'll plug in my upper bound of 18 and subtract my lower bound of 6 to get 1 over 12 times, okay, all of this is still equal to 15. 1 over 12 times 132 plus 18c minus 6c. That's plugging in 18 for t for my upper bound and subtracting when I plug in 6 for t for my lower bound. So I'm left with 1 over 12 times 132 plus 12c equals 15. And now we just need to solve for c, and we're done. Okay, so I'm going to multiply by 12. So that gives me 150 plus 30 is 180, is equal to 132 plus 12c. I can subtract 132 from both sides to get 48 is equal to 12c. Therefore, c is equal to 4. If our setting on the machine is changed to add 4 calories per minute that we want to burn to our function, then in order to average burning 15 calories per minute, we would have to set that dial on the machine to increase our calories per minute burned by 4 calories per minute. Okay, here's our scoring guide. So we've got 2 points, 1 point for our setup, so that would be our average value equation set equal to 15. And then 1 point for solving for the value of c, which is 4. Any questions on what we did here?
No.
Nope. Okay, I do have one more word problem that I want you guys to try, which will be our homework for this time. I know some people are still working on their partial fractions homework. It was long. I gave us, it's been actually 6 days to complete it now. I am going to still take it